Right. So I am sharing my PPT with you. Hopefully that's visible.
Oh, yes, sir, it's visible.
Yeah, thank you. Right. So yeah, I put together a few slides. Let's go through these slides and then we'll probably have an interactive session after this. And this was aimed more at the B.Tech students and maybe some graduate students can also benefit from this. Let's see how it goes. So I think Dhanush has done a fantastic job of introducing me. Not all of it is true, some of it is. So first thing is, let's talk about when I'm talking about careers in engineering, I want to bring in my perspectives. Of course, there'll be a heavy leaning of what I think is right. And my perspectives are molded by two things. One is I was a graduate of the IIT system itself, so I'm very well aware of the pressures and the leanings of the IIT system and the different pulls that you experience while you are in the IIT system. And needless to say, the expectation of the society from you in terms of what you're expected to bring home after you graduate, as in your pay packet. So that always becomes the driving criterion for a career, and your future choices are often dictated by that. So I'm very well aware of that. And I'm one of those people who is a civil engineer by choice. So having gotten through the JEE system, I had a choice to become, based on my ranks, a mechanical engineer or a chemical engineer, but then chose to be a civil engineer. And then, of course, I was pilloried for that throughout my B.Tech. But that is something I took out of interest, and I don't think I've ever regretted that. So that's the starting point of what I wanted to lay out there. The other perspective that I want to bring here is the fact that I've had the privilege of teaching across two continents. So I've taught in US and in India for 10 years each. I've had again, the privilege of interacting with students there and students here. And I've had the experience of seeing the way the industry and the way the civil engineering in general functions in US and the way it is in India. So I basically will give you in my talk an amalgam of all of these things based on my experiences. So the first thing I wanted to make you aware of is this society, ASCE, which is the American Society of Civil Engineers. Now, ASCE is a society for civil engineers. And probably if you look at structured societies for civil engineers, it is probably the most structured of societies. It actively lobbies for the cause of civil engineers in the US, and they are very organized. So basically, a lot of information related to civil engineering, policies related to civil engineering, all of these are basically championed by ASCE. So we, in other countries, in fact, the associations and societies are not so strong as what you have in US. And civil engineering as a profession, I think, ranks very highly amongst engineering in US. So it's a lot of what I'll present will have a flavor of ASCE because they have a very structured look at careers in civil engineering. And I'll present that later. You'll be able to see of what ASCE projects as the different career options. And then I'll kind of deviate from there and present the Indian scenario of the different careers and career paths. So yeah, so in civil engineering, I'm not going to bore you about what civil engineering is, but if you look at the range of domains, it practically covers everything under the sun. We go from construction of buildings to water systems, and it's basically supplying water to cities, managing the water demand, to managing the waste that comes out of these cities and homes, transportation systems, the structural part, the system handling, whether it is the highway system, the rail system, or the cargo movement of cargo freight. All of this is essentially comes into the domain of civil engineering. So practically every aspect of life is touched by civil engineering. And the price we pay for that is that we are basically very, very, very broad. So when you say, what does it take to prepare a civil engineer? It's all of these things. And if you look at what most of you would are going through as your curriculum in your B.Tech, or most of you who have experienced this during your bachelor's, you would realize that we have these broad areas or specializations that we identify within civil engineering, and these are not the only ones. So we start with environmental engineering, and everything related to environment basically falls into that umbrella. Geotechnical engineering, structural engineering, transportation engineering, water resource engineering, construction technology and management, and surveying, geodesy, and all of these things come under civil engineering. And if you look at the smattering of courses that we usually expect our students to take, it is a huge spectrum that we cover. And you can already see from here, the spectrum is very wide. And basically, compared to other fields of engineering, most other fields of engineering probably have 2 or 3 specializations at most. Civil has 7. And so our curriculum tends to be very, very broad. And oftentimes you kind of sit and scratch your head and say, well, I mean, how are these 2 fields even related? And why am I studying these 2 fields together under this umbrella of civil engineering? But that's just the nature of things. I mean, that's who we are. So one thing one has to expect when one comes into civil engineering is that we offer a very broad base. Our base is very, very, very broad. So that has advantages and that has disadvantages. The fact that we have a very broad base means that we become generalists. After a bachelor's, we basically know enough to be dangerous. And that's one of the problems or one of the issues that we have to learn to address, particularly in civil engineering.
Excuse me, sir, sorry to interrupt, but I guess your slides are frozen. It's still on the first slide.
Okay, you... let me share again.
Yeah, now, yeah.
Okay, let me project. Yeah, sorry about that. So this is. Let me know the slides are moving.
Not yet.
Yeah.
No.
Yeah, let me do one thing. I'll unshare and share again. That's.
Yeah, sure.
I'll just do that. I'll just share again. Yeah, sorry about this. This is one of those wonderful things about technology. Right, so I'm sharing again. And let me go into the presentation mode. Yeah, please let me know if the slide moves. Did the slide move?
Professor,
no,
when you are going in this presentation mode, it's actually not going in the presentation modes. It is just showing the PowerPoint only. So
why is it not doing that? Okay, so is it in the presentation mode now or no?
No, it's still not in the. So are you sharing?
Sir, actually, you need to share the entire screen.
Yeah, that's what I've done. But anyway, that's. Let me just stop presenting and we'll try again. I'll try my entire this thing again one more time. Yeah. Right. So is this full screen working now?
Yes, sir. It's perfect.
Okay. Just let's make sure. Is the slide advance moving?
Yes.
Okay, good. So yeah, sorry about this. So yeah, I mean it's yeah. So as I was saying, we are a very broad engineering. I mean, we include. If you look at the base that we have in civil engineering, it's very, very broad, and it's broader than any other stream or any other field of engineering that you would take or you would consider. So that is one of those things that one has to kind of keep in mind, particularly when you're talking about civil engineering. And this is something that's very hard to explain to people outside, where you have to explain that, look, this is everything under the sun, or everything that you see here fits under civil engineering. So what you do when you graduate with a bachelor's degree is you graduate like a generalist. You know enough about everything. And so this is the what we call the civil engineering pyramid, and this is true of most things. as you learn, there is the breadth aspect of things. So the breadth is shown here. So this is the breadth that you see here, and this is what you learn. We basically broaden we stretch the ruler, we broaden the base, and try to teach you as much as we can and give you enough breadth. Then you have to, through learning and practice is where you basically develop depth. So to move up and develop some depth, you have to basically spend some extra time. And this is particularly hard in civil engineering because the breadth is so wide that you are not able to develop much depth in your through your undergraduate curriculum, through your B.Tech or Bachelor of Engineering curriculum. And so what that basically then does is put stress on learning, either advanced learning, you have to go for a higher degree, either a master's, or you have to go for practice. That is, you go and work in the field, and that's where you pick up practical knowledge and you start developing depth in one of those specializations within civil engineering. So that is the story. Now, coming to the pyramid, if you look at a typical pyramid, when you look at the breadth aspect of it, and when you graduate with the B.Tech, if you look at the bottom of the pyramid, this is where you would stand right out of B.Tech. And basically, you don't, the bottom says that you don't even know what you don't know. So that's the whole point, is that you know enough to be dangerous, but you don't even know what you are supposed to be knowing. What is the full extent of things that you're supposed to know? So that is where you stand. And that is probably more true in civil engineering than most other fields. Then as you climb the pyramid, then you realize that the stuff you know, that you start knowing a little bit of things, and the stuff you don't know, you clearly start delineating or separating those things out. You start developing an appreciation for some specialization. And of course, as you keep digging deeper and develop more depth, then you know your stuff, and that tends to be in one specialization. So that's the pyramid that you have to climb. And typically coming out of a bachelor's, this is where you'd be. You'd be basically at this bottom where you don't even know what you're supposed to be knowing. So that kind of makes somebody who's graduated with the B.Tech actually more dangerous, because they don't know the limits of their abilities. So now, this is something that I want to stress, and civil engineering is basically a practice-oriented engineering. This is unlike other fields of engineering. We are more practice-oriented. What that means is that if you want to become a civil engineer and you want to continue your career in civil engineering, you only learn through practice. And basically, there is a chart of that basically maps your value as a function of your experience. So when you come out of your B.Tech, this is where you stand. Your experience is basically 0, and your value that you bring to the table is close to 0. So when you were to start, if you were to start working right out of your B.Tech, what a potential employer can expect from you is not much, because you do not have much practical experience, and that's the hard part of civil engineering, where you have to learn through practice. But as you start, and what I define as value is, what is your contribution to a project? How much can you potentially contribute to a project? That will be very minimal. You know enough from your whatever you've learned through books, but the rest comes from experience. You have to be willing to be able to spend the time to learn the practice, and that's when your value starts increasing. And the beautiful thing about civil engineering is, as you gain experience in the field, your value starts increasing almost in an exponential kind of a manner. It grows up, it grows very, very rapidly with experience. And as your value increases, that means that what you're contributing to a project increases, then your what you bring home, or your take-home salary, also increases. So that's the graph that one should keep in mind with any field that is practice oriented. And there are things in civil engineering that we can teach, which we do teach, but there are things that we cannot teach. Those have to be picked up on the site. You have to go get yourself dirty and learn the field. And you see the initial part of this graph itself is quite flat. It's actually, you're simply grinding away and learning. So you're not adding much value because you're actually picking up the practice. And then slowly you see that it starts picking up. And this photograph that you see on the left-hand side, this is a photograph that had gone viral, making mockery of the graduating class of 2021. But if I was to send a group of students on the site, right after B.Tech, this is what I would expect them to be thinking of a house. And then to be building it is going to be anybody's guess. So this is where you stand. And this is pretty much the figure that one should probably conjure up when you're looking at your experience, as in the field experience being 0. So what you can contribute to a project would be 0. And the rest has to be learned through practice. That is one of the key things about civil engineering, is that it is a practice-oriented engineering, unlike other fields of engineering which do not require so much practice. And this is probably particularly true for writing code. You can sit and write code in your hostel room, and what you would be doing when you work for an employer is practically the same thing. That is not true for civil engineering. Now, the other things about civil engineering, and this is perspectives from the field, most of what we do, we deal with large projects. Civil engineering projects are basically very large, and they involve a lot of heavy resource and capital mobilization. They're usually expensive projects. A lot of capital or money is involved in it. Money gets tied up over a long periods of time. Civil engineering projects tend to run over years, not days. And basically the failures in civil engineering are very costly. They're very, very expensive. So in fact, this is one of those figures that made the cover of ASC magazine, where it says that for a civil engineer, there's no such thing as a little mistake. And you can see this is a bridge that started from 2 ends, and a small alignment mistake can be quite catastrophic in completing the bridge. So now, as one would have it then, because of this, the field is very conservative. So civil engineering as a profession is a very conservative profession. And because of all of these things, people value experience. So the experience is what you get paid for. Now, I'll just identify or go over the different career paths that are identified in ASCE. These are things that I've simply copied from ASCE. So they identify one of the career paths is working for industry. So here you're working as a part of a bigger team. So when you say industry, and so what is shown here is a windmill. Suppose you're working, you join a firm that is into wind energy. You'd be a part of a bigger team, and of course, you would be responsible primarily to oversee the design and construction of facilities. So here your role is one of support rather than the main engineering, because the main focus is going to be something else. You'd be involved in maintenance and operation. You'd be instrumental in new ventures requiring environmental site assessments and feasibility studies, etc. So environmental site assessments, feasibilities, these have become very important now, and those are done by civil engineers. So when you're working for this industry as such, you're a part of a bigger team where the role of a civil engineer becomes primarily a support person. The career graph of somebody who joins industry is also mapped out by ASCE. One would start out as an entry-level engineer, and it soon branches out. So you go either into technical sales and marketing, you could basically take that career path, or you stick to engineering and basically follow the engineering path and become a project engineer, get into facilities management, which basically means managing the facility once it's been built, of course, the civil aspect of it. And then, of course, all these paths, if you progress along the company, would take you into senior management where you become an executive. This, by the way, is as it is laid out in ASCE or laid out by ASCE. So the 3 branches that if you were to look at in industry would be technical sales. You could branch off and get into technical sales where you're pitching projects to clients. Engineering support, of course, that's what you'd primarily be doing, and sometimes you may get the opportunity to get into a little bit of R&D, or some of these bigger companies may have research and development wings where you could probably work in the R&D part of the industry. The other career path, and this is by far probably the most popular career path for a lot of students, is the consulting. And here, the way they define consulting is to devise and implement civil engineering designs design solutions for a wide variety of projects and an array of clients. So basically, you're here looking at providing solutions for clients. So you're a consultant, and usually you have consulting firms. The size of consulting firms varies from the small, this could be a 10-member firm, to the large ones, which are multinational, which have a global presence. So the scale of operation varies. And of course, that then also has an impact on the size of projects that they'd be handling. So here you start with basic engineering evaluations, so computations, and provide design solutions. That's what you're called in for. And you have specialty consulting firms practically in all fields of engineering. You have structural engineering, geotechnical, transportation, environmental, and management. And that's also now coming to the fore now, where you have a lot of consulting firms that offer expertise in project management. And if you look at the career path here, you start off as an entry-level engineer, then you become a project engineer. So by the time you come to a project engineer, you're starting to look at the complete project rather than a small component of it. So at the entry level, you're pretty much told what you're required to do. By the time you gain enough experience, you become a project engineer. That is, now you're looking at things from a larger perspective. So you start looking at a project scale. Then, of course, the career path, typically even in a consulting firm, branches off. So you could continue in the technical track. That is, you continue just working on the engineering part of it. Then there's always the management track. Here you start looking at managing the projects, and the business development track. This is where you start looking for clients. You start looking to get clients for the company, and basically developing business for the consulting firm. And of course, the choice of these would depend upon your innate ability. What seems to interest you? What would you rather do? For those who are more technically minded, they usually continue in the technical track. And for those who have more of a sales kind of attitude, usually get into the business development track. And of course, all roads would eventually take you either to the CEO or the president of the company. Then construction. This is, if you were to get into construction, the whole point, of course, the ASE puts sugar coating on it. They say you build a sustainable future, ensuring safety and excellence of the built environment. So here you're dealing with all things construction, whether it is buildings or transportation infrastructure, that is bridges, dams, roads, bridges, etc., or hydraulic structures. You could be building, be involved in the large mega projects of dams and the large hydraulic projects. And if you get into construction, typically you work for a contractor, and you're working either in building to create the built environment, that is your homes, office space, commercial space, etc., or transforming engineering and architectural design drawings from paper to reality. This is where the rubber hits the road. This is the person in the field who's out there actually building something. The career path starts off at entry-level engineer, goes to a project engineer, then you become a project manager. So by the time you become a project manager, you're practically handling a project. And here's something that if you get into the construction career path, by the time you come to project manager, you're actually managing an entire project. So you would have a team of people under you, and you are entrusted the responsibility to deliver the project. Then you, of course, if you get along, then you eventually, of course, end up in senior management, become an executive vice president of the company. So this is basically the typical corporate structure that you would climb. Now, construction comes with its own challenges. This is typically, this is a blue collar kind of an assignment, particularly in the lower rungs when you're in the entry level or the project engineer. It is blue collar. You'd be standing out in the sun, rain, making sure that things are getting built. So this is, and your interface is oftentimes not always with technical people. So you're interfacing with a lot of labor, semi-skilled people, so all kinds of people. So in addition to your technical knowledge, your interpersonal skills and all of these matter a lot if you want to get into construction. The field that, of course, I am in, and that is education. And we basically put ourselves as shaping the future. So that's what we like to advertise our field as, and prepare the next generation of professionals. Either prepare them or ruin them, one of them. So we basically are experts, supposedly experts in that. So I wanted to throw this out as a career path as well, and this is also as per ASCE. So one of the beautiful things about education is that we are involved in teaching and curriculum development. So that's anyway obvious. We teach, we also are involved in curriculum development because we are developing new courses, new streams of engineering are coming. The fields of engineering, even the traditional specializations that we have, are seeing a big change as we are progressing. So all of this has to be accommodated in our curriculum. We constantly keep updating our curriculum, what we teach, how we teach. All of that is, of course, in the education. But there's an aspect that a lot of people are probably not aware of, and that is under the education umbrella, we also conduct research. So typically, pure teaching jobs are rare. Most teaching jobs also have a very strong component of research. And this is aimed at developing advancement in the field of engineering. So basically, this is where the push of the envelope, or basically creating the new knowledge, comes in. So this is an essential part of the education, the portfolio. And if you look at what is expected or what is required from for somebody who wants to pursue a career in education or academia, as we call it, one would have to have an advanced degree. So a PhD would be required at the very least. And the hierarchy of somebody in academia is you start off as an assistant professor, then become an associate professor, then become a professor. And then, of course, there are these administrative roles of either becoming the department head or the dean. And if one gets into administration of the universities, then you become a provost or a vice chancellor, and so on, director, etc. Now, this is for the path of somebody who has come through academics, but there's also a path available for somebody to get into teaching with good industry experience. So, but of course, PhD is required. So for somebody who has worked in the industry, has gained good industrial experience, are sought after by the academic institutions. But of course, they should have a PhD. And this lateral entry, which we don't see much in India, but it's actually quite popular in US and Europe. They're called practice professors. So these are people who come with industry knowledge, and they are basically there to teach all the practice-oriented courses to the students. So that's something that is also available, and we are starting to get into that in India as well, where we are starting to look to appoint industry chairs, industry professors in our academic institutions. And the final thing, a career path identified in civil engineering is the government, where basically you're looking to join the government, either the local, state, or the federal levels. You basically get involved in shaping public policy. And this becomes very, very important, particularly for civil engineering, because most of projects are so big. When you're talking about a big, say, hydraulic project, or a water project, or a transportation project, there are usually a lot of environmental issues, a lot of public issues that are involved, and that needs shaping of public policy from the government side. So there are avenues available where one can get into government and look at either shaping the public policy or implementation of the government policy. These choices are a little limited in India. They're basically more in the US. Even there, probably it's a small fraction of people who get into it. And one becomes a bureaucrat in a sense, if you were to get into the government, choose the career path of the government. The path, the hierarchies would basically take you up the rungs of the government. So just like any other private organization, you'd go there. So to give you an example of this, you could join an agency like the EPA, the Environmental Protection Agency. It's a governmental agency that shapes policy, environmental policy. Similarly, I think in India, we have agencies like the Central Water Commission, which shapes policy about water distribution between states and all of these things. And it's primarily staffed by civil engineers. So that option is available. These are limited options. National Highways Authorities of National Highways Authority of India. This is another agency. It's a government agency, which is basically handles all things related to highways and transportation in India. So these agencies are there. The government agencies are available. They're primarily staffed by civil engineers. And there, of course, the engineering knowledge only goes so far. You very soon get into public policy and how to figure out where to invest the government money, how to manage the large public projects, etc. So these are the different career paths as identified by ASCE. Now let's look at the employment and career opportunities from the Indian perspective. So typically, if you are looking at continuing or working in design or construction or consulting, then your options are between the private sector or the public sector or the government. And I'll describe these and how you could get into either of those. Then there's always research and teaching that is available to you. And of course, there your choice is limited to academic institutions. Pure research, it's a very limited choice. It is available. And of course, here we have agencies like ISRO, BARC, CSIR Labs. All of these are pure research institutions where they do recruit civil engineers, and they need civil engineers for handling specific aspects of things related to the agency. For instance, BARC has a very strong group of civil engineering. They have groups which handle aspects of structural design, because reactors and reactor designs require special care, which are not handled by most of our conventional design codes. So they have their own design codes, which are developed by BARC. Then there are also very strong groups that look at seismic and earthquake vulnerability of these structures, do scenario forecasting, etc. And those again are housed by civil engineers. Now, CSIR labs, there are CSIR labs which are specialized in civil engineering aspects. So you have the Structural Engineering Research Center in Chennai. You have the CRRI, which is Central Road Research Institute, CBRI, which is the Central Building Research Institute. So these are all CSIR labs which specialize on applied research. So the research that they do is very applied in nature, but with a focus in civil engineering, different aspects of civil engineering. So these are the different career opportunities that would be available for you in civil engineering in India, depending on your choice of career path. So coming to government now, suppose you want to get into government. One of the most popular choices, it used to be for civil engineers, was the IAS, the Indian Administrative Service, which is, of course, the entrance of that is through the civil service exam, which is conducted by UPSC. It's a very, very competitive exam. And here you're directly essentially become a career bureaucrat. And if you were to get in here, of course, you could end up with a field like the Indian Police Service or the Indian Foreign Service. There's also the Indian Forest Service. You, depending on how you place, you could get into one of these streams. And then, of course, engineering goes bye-bye. You pretty much sit and look at administration. That's your prime goal here. But through UPSC, one could also get into the government through this stream of IES, which is the Indian Engineering Service, which would open the doors for you to get into agencies like the railways, the CPWD, which is the Central Public Works Department, the MES, the Military Engineering Service, and there are several other branches of engineering which are central or they are basically under the central government. And they here you basically join as an assistant executive engineer. That's the rank at which you join if you clear the IES, the Indian Engineering Service exam. And you rise through the ranks, and eventually you could become a chief engineer in these any of these agencies. One could also opt to join the state government through the state service commissions. Each state has its own service commission. You get in through either written exam. Each state conducts its own written exam. And you would get into the PWD, which is the Public Works Department, which is for the state. The R&B, which is basically roads and bridges, which handles the construction of roads and bridges in the state. Water, panchayat, etc. So there are different groups or agencies within the State Service Commission, or the options available with the State Service Commission. So these are the streams that are available if you are interested in to join either central government or the state government. And these are hardcore engineering jobs. So basically, you would be working as an engineer in these fields. Coming to the industry, the public sector. So if you are interested in joining the public sector, here most of the public sectors are public sector undertakings, PSUs as we call them. The selection is usually at the national level. Now I think they admit or they take applicants through GATE. And this figure kind of shows you the different sectors that are there for you. And as you can see, most of these are nothing to do with civil engineering. So if you, let's say, take the oil sector, their primary business is producing oil and bringing it to the market. So our role as civil engineers here would primarily be a support role, where we're looking at construction of facilities to facilitate or to help out with the oil exploration, and whatever support facilities are required for transportation, for housing, and for distribution systems of this oil sector. Similarly, if you look at SAIL, their main business is steel production. So civil engineers would find use there, again, in support roles to help out with the facilities construction, facilities management, maintenance, etc. So these are different sectors to which you can gain entry. And these are, again, engineering jobs which come with the PSUs. So there are different private employers as well, and depending on your career path that you choose, you could get into construction. If you get into construction, there are, of course, the very large companies like L&T. Then you have Shapurji, Palanji. These are all multi-billion-dollar companies, and construction is a career path you can choose with these companies. You could get into consulting. Most of the consulting firms are private. Most of the consulting firms typically offer design service. So they are design consultants who give you design solutions. And even the government agencies like the CPWD or the different PSUs would come to a private consultant for design solutions. So when they are constructing a new facility, typically they'll bring the problem and give it to a private consulting firm to give them the final design solution in the form of design drawings or in the form of design calculations of what would be required to construct that structure. Then consulting, now this is also taking off, and that is project management. This was one of those fields that going forward, I think we'll see a tremendous growth. That's because it's not just enough that we are constructing structures, but we need to bring in new technology into construction. And that adoption of technology is becoming very, very rapid in India. And as we mechanize, we are starting to think of managing a construction site just as you would a production line in a factory. So now we're thinking of optimizing the resources. We're thinking of maximizing our profits. We're thinking of shortening our time of construction. So all of that falls in the domain of project management. And there are specialists or consulting firms who specialize in providing project management consultancy. So they would be basically the managing the entire construction project, right from the funds to the scheduling of the activities, to ensuring that the entire structure or whatever project is there is completed on time, within budget, and all the resources are used effectively. Now, then if you look at private employers, there are other companies, there are other sources one can look at. There are cement companies now. We have a lot of cement companies who are looking for civil engineers. Of course, one should be interested in working in such company. Specialty products are now coming into the market, a lot of construction chemicals, precast products, etc. So there are, these are also potential employers, and they're looking for civil engineers. And specialty services, this is becoming another segment that is growing quite a bit, particularly things like repair, where we're talking about repair of old structures, rehabilitating old structures. So these are all specialty services, again, where there is a good demand for civil engineers, and most of it is handled by private companies. So when it comes to private consulting or construction, we usually look at building design and construction, and of course real estate is a segment of that. Then infrastructure is a big employer. This is where a lot of civil engineers get employed because these are big projects. And then you're looking at highways, airports, SEZs, etc. So, and this kind of construction is typically handled by big private entities, which have the wherewithal, deep pockets, and they employ a lot of engineers in infrastructure projects. Then, like I mentioned before, construction planning and management. Water resources, so you have a lot of private players who are into construction of dams and hydraulic structures, and all fields of engineering would find employment in most of these areas here. Now, as I'm starting to kind of conclude, I just want to throw this in there before I conclude. And this infographic or this graph here shows what your life would be or what your career would be if you were to join one of these consulting firms, or if you were to join, say, a construction firm, or if you were to join even the government or the private sectors. What I have on the y-axis is just a percentage. And what I'm plotting is a percentage between engineering. This is your hard engineering skill and management. And this distinction has to be made because, as I had mentioned before, when you start out as a project engineer. You do what you're told to do. You're basically instructed, this is what you'll be doing. And by doing so, you slowly gain experience. But what happens is that as you start gaining experience, what you would see here is that the engineering component, which is the top triangle here, that starts decreasing. So the amount of engineering that you do starts decreasing. You'd be expected to do a lot more management. And if you look at it, it's a total net 100, it should sum to 100. So somewhere, suppose in the middle of your career, you'd be doing, say, X of engineering, and 100 minus X goes into management. So at some point of time, you'd be expected to lead teams. So you go from a project engineer to a project manager. So there you start managing teams, and that is expected of you. So and then as your management component grows, or what you do in terms of managing the teams and giving directions, then taking decisions with financial impact. So basically there you're entrusted with the decision making, which has financial impact. And so if you look at it, when you start out, you'd hardly have any decision making capability which would have any financial impact. You do what you're told to do. But as you start coming up here, maybe later towards your career, your engineering component shrinks down. So at that point of time, what you'd be doing as engineering will be very small, and what you'd be doing in terms of management would be a much significant portion. So your job there, as you progress and you spend several years gaining this experience, is to provide a bird's eye view, to provide the vision to any project. So you basically look at a project and say, okay, this is the direction we'll take, and then you leave it to your subordinates to give out all the details. So that's typical of a career path in any organization or any setup that you see. So you start out from here as a novice looking at a cartoon sketch of a house, to somebody who's basically now sitting in a nice air conditioned office, and then you're now looking at decision making. You're a part of bringing business to the organization, and you're part of managing the system. So that's something that is to be expected as you progress along your career. So just a few final things, and that is what are the steps that you should take or you can take for your advancement. First thing is work experience. That is absolutely essential in civil engineering. You gain experience only from work if you want to have a career in civil engineering along any of those 5 career paths that I've shown. Licensure as a professional engineer. This is something that we don't have in India. There is an engineers bill that is being introduced, and if that goes through, then we will expect engineers to be licensed professional engineers. And what that means is that after you gain certain experience, certain amount of experience, you pass a test, and then you become a professional engineer, if you, of course, pass that test. or any and all designs or drawings have to be stamped by a professional engineer for them to be valid. This is a prerequisite for a safe drawing. We do not have this setup in India. Of course, it's a standard practice in the US, and that's what keeps the value of civil engineering very high, is that professional licensure. It's being introduced in India. So hopefully in the next few years, we'll have this professional licensure of engineers in India. Now, one of the essential things here, and this is, I am talking about career paths and all these things, is oftentimes what we get discouraged with is the starting salary of civil engineers. And there are two reasons for that, particularly in India. One of them, of course, is that it's a practice-oriented field. So, if you, right out of your B.Tech, if you were to go there, you would not know what you could contribute in a positive way to the company. So you have to be patient, learn the tools of the trade, and then your value builds up, as the graph that I had shown. But there's also another aspect that is very peculiar about India, and some of you who will be going out to work will realize this, and that is we in India have this peculiar way of equating things, where we say B.Tech with 2 years experience is equivalent to a diploma with 5 years experience. Now, these are two very different educational degrees with very different educational outcomes. And we somehow tend to equate them. And what that has done is that it has completely taken away the bottom from civil engineering, and it has completely killed the bottom. And that is the reason why we don't have a certain minimum salary in civil engineering. It is artificially depressed because of this equivalence that a lot of people who are hiring at the lower level try to force. They try to, I mean, the logic is that I can hire 2 diploma holders or 3 diploma holders for the price of 1 B.Tech. And that's a very sad part of the entire equation. That will go away if you have licensure, because licensure would basically ensure that only engineers can do the job of engineers, and that would automatically raise the bottom salaries that we command as civil engineers. Now, advanced degrees such as master's degree in civil engineering. So this goes to answer the depth perspective. So if you want to get that depth by means other than practice, of course, you cannot completely eliminate practice if you want to be in the field, if you want to have a career in civil engineering. Nevertheless, master's in civil engineering gives you that added depth, at least along one of these specializations, which makes you a little bit more useful to the company. And as I had mentioned, public administration and business administration, at some level, some skills would have to be picked up, because if you want to continue in that career, as you grow along, you would have to develop managerial skills. And of course, a PhD, if you can get it later, would open the door for research and academia for you. Right. One of the things that is stressed quite a bit is this continued professional development. In civil engineering, this becomes very, very important. So even after 20 years of working in the industry or working as a civil engineer, you have to keep upgrading your skills. That means you keep coming back for learning the newer things that are happening. So that's one of those things that is highly advocated by ASCE. Right. So just to conclude, I know I've kind of rambled on for a long time. The last thing I want to push for, of course, this is something I didn't want to push too much, but I can't leave you without at least canvassing for it. And that is career in academia. A lot of you, at least those of you who are inclined, have a research bent of mind, this is a very good career option that's available. Now, the positives and the negatives of this: the salary in academia is competitive. So it's actually quite competitive with the industry. The best part about this is the freedom that you get, the academic freedom that most of us enjoy as academicians, as faculty in institutes. And there is no set agenda. You set your own agenda. You decide on the topics that you want to research on. There's nobody telling you to do something. So that is the freedom that you enjoy. So even if the salary is not maybe 100 to 100 match with industry, the academic freedom that you enjoy, I think, far outweighs the monetary loss that you may suffer. And also the respect in the community. So that's one of those things that particularly, at least in the Indian society, there's still a very high level of respect for academicians. So with that, I would like to conclude my talk, and maybe we can have interaction. I can take some questions, we can have some discussion. But the one thing I have to mention here is that if you're planning a career in academia or research, it's front loaded. You have to put in all your effort in the upfront. So you have to prepare for a master's and a PhD, possibly even a postdoctoral appointment, where you do a postdoctoral fellowship for a few years. So it's a long haul. You're looking at least 10 years of education after your 12th standard minimum, and another couple of years for postdoc. So you're looking at 12 to 13 years of preparation before you can get into this academic line. And most people usually tire out of this and prefer the easier way out, which is basically the business route or the consulting route, not the civil engineering consulting, but a lot of students tend to go for other venues like banking, finance, etc. And then, of course, they branch off, get MBAs, and then that's a different story where then your engineering background is of no use to you. So with that, I'd like to conclude. Let me stop sharing my screen and let's have some questions.
Thank you, sir, for such an informative talk. So thank you for touching upon like most of the elements of the civil engineering profession and all. So now the floor is open to questions, and you could type in on chat box, or you could unmute yourself.
Okay, I see there's a question already on the work cultures in, what is it? Sorry. So India and abroad, more context to structural engineering. Oh, okay, more context. Yeah, I'll try and avoid the context to structural engineering. Let me tell you a little bit about the work culture here and there. The work culture in US is a little bit more informal. So it is not of first name basis. Even the senior man in the company would be on a first name basis. Then you work hard and you play right. So that's the attitude in US. That is, you work for 5 days, you get your weekends off, and you try and get most of your work done within the working hours. So it's people are very professional, where very little time is wasted chit chatting and doing other things, where you try and get things done. And deadlines are deadlines. So when something is committed, it gets done no matter what. So that is very typical of the work culture, and that's not just of civil engineering or a structural engineering firm, but that's true entire of any company or any agency in the US. Now, having said that, I think when you come to structural engineering or say civil engineering, the stature of civil engineering in US in particular is quite high. So it attracts some of the best students. And the reason there is the growth path of the salary structure, the way it grows in US is exponential with experience. So, and the reason for that is as you gain experience, your value increases and they recognize you for it. So your salary grows practically along an exponential trajectory. Whereas if you look at other fields of engineering, suppose you look at computer science or electrical engineering, their starts tend to be very high. So yes, the starting point of a computer science major or an electrical engineering major would be higher than the starting point for a civil engineer. But their growth tends to be linear. So what happens is that the civil engineers catch up with the other majors within about 10 years. And after that, usually the civils are making more money than the other majors. This is, I think, what people are aware of, and those are willing to put in those, little bit of extra work for the first 10 years, eventually reap the benefits. That's one of those first things. The second thing that happens in US is that the civil engineering field is quite tightly regulated. Agencies like ASCE play a special role in regulating the quality of output that comes from colleges. Also in ensuring that civil engineers have proper respect. So in the US, no project can be taken up unless it is signed off by a professional engineer, a licensed professional engineer. You cannot even construct a wall in your own house without it being signed off by a professional engineer. So that is the level to which the engineering is literally a part of every little construction activity, civil engineering in particular. So that then raises the value of civil engineering. So civil engineering salaries tend to be higher. Even this bottom is not as low as what we have in India. The growth tends to be very rapid. And once one becomes a professional engineer, their value to the company increases. And so the salaries also increase tremendously after that point of time, because at that point of time, the person can stamp a drawing which can be directly issued for construction, or the person can stamp a drawing which can directly be implemented. Suppose it's a transportation project or an environmental project. So that's the way things are handled differently there compared to us. We are slowly realizing that we need to be more organized and probably bring things of similar nature in India. So those hopefully will bear fruit in a few years. We'll have to see. Competition level education jobs there, much of a cat and mouse race? No, it's not. So yeah, I mean the whole problem of competition. We have a very competitive education system in India. It's not as competitive in India in the US. So that's one thing to show. And if you were to ask me, the level of instruction, having taught in both places, is almost similar here and there. I didn't see much of difference. What I do see as difference is the abilities. While we are very good quantitatively, I think most Indians are extremely good in our quantitative skills. Where we lack is in creativity. We do not have the ability to think creatively. We do not have the ability to apply ourselves. And we are not at all practical. In other words, if I was to take a group of students to the field and say, okay, here's some wood and try and build something with it, most Indian students would fail miserably. Whereas the students in US are very hands-on. They're very good with tools and application. They're very creative. So those two things kind of tend to balance out. So Indians make very good engineers, but they don't make good managers. Whereas usually what I found is that the students I taught in US were more attuned to becoming good managers. So that's just the difference in the education system. But the education system is not so competitive. When we're placed in a certain company after just completing B.Tech. Yeah. So when after completing a B.Tech, like I said, you would basically join as a project engineer. So you'll pretty much be told what you'll be doing, and there'll be a lot of hand-holding at that point of time. So to give you an example, when you join, let's say, a design consulting firm, they could say, fine, here design some beams, and here go design some columns. So you would basically sit and do those component level designs, and the person senior to you would then be doing some level of integration, and the person senior to him would then be integrating that at the project scale and all that. So right out of B.Tech, you basically start out as a project engineer, where you're looking at the component scale things. You're still learning, and it'll be a good year or 2 years before you get some idea of a good idea of even the component level things. And after that, you start looking at the big picture. When you start looking at the next step and the next step, how to integrate things, right? Do we need to go for an MBA? Yes. So this, I'm presuming, there's a question that says, for stepping into management side, do we need to go for an MBA in an institute like IIM? Yes. So there are two aspects to this thing. One is the purely commercial aspect. If you're only thinking pay packets, not a career in civil engineering, then there is this thing called brand hawking. So what that means is that you already have the brand IIT under your belt. Now you need another brand, which is IIM. So you get yourself stamped with a. It's not an MBA. IIMs do not give out MBA. It's equivalent to that, but you get essentially a degree. It's a diploma what is given by IIM. So you get a diploma in management from IIM. So then you basically carry two strong brands, and you get into whatever you're trained for at these IIMs, whether it is finance or marketing or sales or whatever it is. And then your civil engineering background after that point is useless to you. But then there's also another aspect, and that is you're working in a company, let's say like, and I'll just throw this for in a general manner, and that is, suppose you were working for a huge conglomerate like L&T, and you started out as a project engineer, and you're working your way up, and at some point you have come to a realization that, look, now I'm managing teams and I could use some managerial skills. So companies like L&T actually have special streams at IIM. So these are companies would sponsor you for a management degree at, or a diploma at IIMs. So there are joint courses in management even offered with IITs. IIT Madras and IIT Delhi have special courses offered to people who come from the construction side, and then to give them the management flavor. So those are options are available within construction, and a lot of companies do have this career growth opportunity available. How does climate change policy govern the working of companies? Are there masters courses in climate change solutions or policy abroad? How will that play out finding a job? Yeah, so climate change is one of those things that is the big elephant in the room that we all see. We pretend that it's not there. So climate change is those who specialize in climate change would find would essentially be looking at policy decisions. So a lot of climate change work goes into feeding policy, because governments are now deciding policy, and we need to prepare for this. It's happening. So now, how do I bring about a change? So something as simple as, say, banning carbon burning vehicles or diesel or petrol vehicles, and bringing in electric vehicles. Those kind of policy decisions need very strong support from climate change people who specialize in climate change. So a lot of climate change goes into government policy, and people usually find employment in government, in policy departments, government, proper government with policy institutions. There are agencies which handle this, like you have TERI, the Energy Research Institute, and there are several other agencies which do this kind of work, which help the government with policy framing, policy with the decision making related to climate change. Okay. Now, of course, when the question was that how would this compare to India or abroad? Probably, I think abroad, Europe, I think they are a little bit more advanced in this. They are very serious about climate change. US, you have agencies like the EPA, Environmental Protection Agency. These agencies do a lot of work for in this specific aspects. And there are agencies like NOAA, which is National Oceanic Administration, NOAA, yeah, who also do a lot of climate change related work from the ocean perspective. So these are all government, semi-government agencies which help the government understand the big picture, essentially. Is our curriculum meeting the requirements of industry? What skills students have to equip before they get into industry? Yes. So now, if you're planning to seriously get into industry, curriculum can only prepare you so far. We do our best. So we have a very broad set of specializations. So if you look at civil engineering, we have 7 specializations, and we have to make sure that we prepare you in each of these streams. Now, when I was doing my B.Tech, we had a curriculum which was much more extensive than what we are offering you. Of course, at that point of time, there were 2 things which were enforced on us rather ruthlessly, and that was every semester we were expected to take 35 to 36 credits. That was a requirement. So that left little or no time free for any other activity. And the second thing was, we did not have so many options in terms of liberal arts and creative arts and all these things. So the breadth in terms of personal development, we didn't have much. I think now what has happened is that the curriculum has shrunk. So we've actually reduced the credit quite a bit. And I think now, on an average, you take about 20 credits. That's what an average B.Tech student takes in a semester. And that itself is considered heavy. So now compare 20 to 36. there's your comparison. So you already lost out in credit in terms of what we can offer. And the other thing is the other part where we are now adding, or we've added things, more items like liberal arts and creative arts, which help you broaden your horizon, which is actually quite good. But that has come at the cost of taking away our core. And now if I am asked to shrink the pie and cut it into 7 pieces, then each piece only gets so much. So that's one of the problems we are grappling with curriculum. And even at the master's level, we are not able to offer the level of the depth that we need because of curriculum restrictions. So yes, we are only able to teach as much through our curriculum. The other part has to come from experience. So while you're studying, internships, I think, are a very good idea. You should look for internships to spend your summers, even the winter breaks, working for industry, where you get some exposure to these industries, get some flavor of what practice is all about. And the remaining part would have to be picked up on the site, on the job, when you actually go to work. So that's the essential part of learning, which has to come through practice. Yeah, so please comment on placements in civil engineering in IITs. Okay, placements in civil engineering in IITs typically tend to be dominated by banks. So that's the big pay packet. Everybody runs after a pay packet, so we manage successfully to place best and the brightest in the banks. So that's a given. Now coming to the other placements in core engineering, we do have core engineering placements. There are few, and part of it also has to do with the fact that the starting salaries that are offered by core engineering industry or core engineering sector is low, and that puts off a lot of students. So what we have seen in the past few years that I was handling the placement was that a lot of students would not show up for pre-placement talk because the salary levels that were offered were low. And this is even companies like L&T and TCE, Tata Consulting Engineers, which are pretty much the top consulting firms or construction firms in India. Even their base is low. And sometimes these companies intentionally keep the base low because they only want to bring in the motivated person. They don't want to bring in somebody who's there for money. So they've taken somebody as a GTE, a graduate trainee, and for 1-2 years, they put you through the training. And then your salary starts seeing a rise after that. The first 1 year or so, the salary, or 2 years, the salary would be quite flat. That puts off a lot of students. And we've seen that has shown up in the attitude of students when they show up for interview. So that's one of those things. But if you go with an open mind and you're willing to put in the time, get into the profession, spend the time, gain the experience, I think there are enough jobs in India to be had. Yeah, what is the future forecast for placements in civil engineering? Will there be a boost in employment level? Yes, there will be. A lot of investment is being made in infrastructure today. So all of that eventually will turn into jobs for engineers. So that's civil engineers in particular. So that's bound to happen. New fields of engineering that are coming up, as when I say new fields, I should be careful. Fields like environmental engineering, transportation engineering, these are fields that 20 years back had practically no employment opportunities. But now we are coming face to face with the fact that we need proper engineered solutions for our environmental problems. We need a proper engineered system for transportation. So these are two very rapidly growing sectors in terms of employment. And we're finding that a lot of, we do not have adequate expertise in these areas in India. And oftentimes the firms that offer consulting service in these areas are imports, or they are basically firms that are based out of India. And now they've come to India in search of opportunities. So that's one of those things to think about. But yes, certainly I think going down, we will see definitely an improvement. How do we assess our growth while working in civil engineering firm? How do we get to know what skill and learning is required for growth in a particular sector? Yeah. So this is one of those things, I think, as you're working, you yourself will come to the realization. And that is because, like I said, we teach what we teach. I mean, you know what we done. So when you graduate, you've learned whatever the textbook had to offer, whatever the professor was good enough to teach you. But as you're working, you will find that going to a textbook for solutions is often not the solution. And you will not find ready-made solutions in textbooks. That's the true nature of the job of civil engineers in the field. And that's when you start realizing that experience matters. And then at that point of time, you start looking more for what you're learning from your seniors there, who basically would be teaching things to you. A lot of these companies have their own internal resources, which you know will be at your disposal, from where you can pick up things. So these are things that then become your streams of knowledge. In addition to this, of course, then you have the advanced degrees. So those of you who would want to then still gain some additional theoretical knowledge in addition to what you're learning on field, you come back for a master's. There are several certificate courses that are available, which you can do to enhance specific aspects of your thing. Then workshops are organized by either IITs or even by professional societies. These workshops are typically on very focused areas, so you can partake in those. So these are all the different streams that you can use for learning, enhancing your skills. And then at some point, like I said, you also would feel, at least some people are natural managers. They tend to automatically gravitate towards leading teams. And so for them, management comes as second nature. But some people, it is not so natural. For them, then you can always go and look at either a degree in management, or you could go for a company-sponsored diploma or some certificate course in management, just to kind of get a flavor of management techniques if you want to be formally taught in those areas. Right. And how to assess your growth while working as a civil engineer? Well, I mean, it's what you will see when you start, let's say, working in a consulting firm or even a construction firm, is the first few years your learning curve will be very steep, and there's a lot to learn, because these are not things that we can teach in the classroom, even in a lab. So first few years, your learning curve tends to be very, very steep. And at some point, you start realizing that your learning will start to taper off. So you'll realize that I've pretty much picked up a lot from here. And at that point of time, you can either decide to go and get into another company that probably specializes in something else, so that you can keep learning and add another trade or another skill set to your resume. Or you realize that this is the point that now it's enough that I do things by myself, and maybe I should now be looking at leading a team where I assign work to people and get them to do the work, and then I start looking at the integration. So this is an automatic growth that happens. Right. Okay, so you and a lot of us usually give really useful information in culture in USA. Can you please recommend similar development, other developed countries like UAE, Germany? Yeah. So yeah, the culture in, you see, if you're talking about the Middle East and say UAE in particular, the most of the way the big consulting firms there, the big construction firms there, those are all US-based firms. So, and everything there is literally run like US companies. Germany has a very different take on things. Germany realizes that civil and mechanical engineering are practice-oriented engineering, and you cannot graduate with a degree in civil engineering unless you do 1 year of hard internship, and that is, it's a 5-year degree in Germany, or the bachelor's degree, in which 1 year is spent in industry. You actually go work for the industry, and then you come back and collect your degree. That's how rigid they are about this industry experience. And the other thing about Germany is that they value engineering more than management. So if you were to look at, say, companies like the top German companies, like say BMW or Mercedes-Benz, the top people usually are engineers. They're not MBAs. Because Germany thinks that it's engineers who should be running the show. That's a very different perspective on things. So their engineers are respected a lot, and the salaries of engineers are very high. And the way Germans think is their engineering approach is everything is engineering for them. So they're very mechanically oriented that way. And UK is also quite similar in that sense. Japan has huge companies, conglomerates, which are massive, multi-billion-dollar conglomerates that handle construction or any civil work. The issue with the Japanese culture is that they're not as open as the other, say, the European or the American firms are. So most people that work in there realize very soon, working in Japan at least, in Japanese companies, is that one is only able to go up to a certain rank. Beyond that, everything else is cut off and it's meant for the Japanese. They've not opened up to that level. They've not integrated other cultures, other societies so much. So that's one of the drawbacks of Japan. And Southeast Asia, well, the places to work primarily is Singapore. Again, most of it is either UK or US based firms run the show there. So that's the story there. Okay, so what is the best year to start preparation for IES examination? Do you have a special assistive course for the same? Yeah. So IES examination would, this is based on my batchmates who made it into IES. They basically spent one whole year after their B.Tech to study for the IES examination, and they cracked it. So yes, I think coupling IES examination or preparation for IES while you're still taking your going through the B.Tech curriculum may be tough. You may have to finish your B.Tech and then maybe prepare for IES examination. That's probably the best path to take. What is the scope for freelancers in our country? Yes, an excellent question. And I'm surprised nobody asked me about this. So this is one of those things that I think civil engineering offers, where you can start about providing design consulting services or any consulting services as a freelancer. But of course, one of the most essential things here is that you should have enough expertise to offer such a consulting, because now you're an expert. You become a consultant only when you have expertise in that area, which means that you should be willing to spend the first few years first gaining all of that. So to gain that kind of experience where you can branch out and become a freelancer would mean that you probably have to work first somewhere in a good design firm or a good consulting firm, gain that experience, and then you start off on your own. Now, to become a freelancer, you need two things. One is the expertise, the technical expertise, which you would gain, of course, from advanced courses like an M.Tech or something, which will prepare you theoretically. And you still need that experience, the field experience, the practical part, which you gain by working in some good consulting firm or a construction company. But the third most important thing about freelancing is that you have to finally bring business, which means you need contacts. So those years that you spend working in some consulting firm or construction firm should be used to develop your contact base, because ultimately the consulting projects that you get would primarily come through contacts. So that third part of it comes from those few years that you'd spend working for another consultant. Now, as far as the scope for freelancers goes, I can tell you about several of design consultants who've made it very big. They all started small. Sometimes a few of them got together. They started a design consulting firm, and now they're doing extremely well. They handle some very challenging projects, and at the end of the day, you have this happiness about having created something. This is your company. It's your baby that you've nurtured and created something out of it. So that's certainly an option that's available for civil engineers. Right. Now, the only part about freelancers is that if you want to get into construction, then it's a different ballgame, because that's very capital intensive. You need a lot of money to get into it, and you need heavy financing. And in a lot of places, construction, at least the bigger projects, you need the right kind of contacts as well. So that's a different ballgame. But consulting, certainly, you can start out. Yeah, there's one more question. So what about Scandinavian countries? Civil engineering is shown to highest pay. Yes, you're absolutely correct. So the highest paid professionals, in fact, not just Scandinavia, Europe in general. I think Europe, civil engineers are probably the highest paid engineers in Europe in general, and Scandinavia probably in particular. how to land a master's there? Well, I mean, you apply through, there are good universities in Scandinavian countries. You would apply for the master's program directly. Funding, I'm not sure about funding or how generous they are. But again, most of these countries, the Scandinavian countries, Germany, they are practice oriented. So for them, it's very important that you learn the practice. So if you were to say pick up a master's in one of these countries, the coursework and other things that you would do would be less theoretical and a lot more hands-on. So they would basically be more, they're more practice oriented in their approach. So that's the way they handle things there. Application to masters, I think we send out a lot of information circulars which come through placement office about possible opportunities in different European countries. Apply against those calls that we send out. 10 years down the line after B.Tech, would a decade of work experience be valued more, or would 2-year masters in 7 to 8 years? That's a tricky question. Okay. Yeah. So it's hard to say. I mean, it all depends upon what it is that you're planning to do and what it is that you're actually doing. And in the sense that if you get work, suppose you're working in a construction company, then and you are on the site, at that point of time, the masters that you probably come back for would either be a construction management, which would be of use to you, or probably conventional management, where you would look at more finance, financial management, etc. So that's the kind of flavor you'd want. If you get into, say, a consulting firm, then just to add a little bit of that theoretical background, because you will realize very soon that you've learned a lot of things in design, you've learned the practical things. But what practice doesn't teach you is, and I can be very specific, let's say about design consulting, is they will not often give you the theoretical background. So you, for instance, they will, you know, the company that you've been working for, let's say you get to a point of 10 years, you're designing structures, you're designing some very complicated structures. But a lot of it is basically comes down to, say, understanding the code, applying the code, getting the result done. But then at some point of time, if you have the intellectual curiosity saying that, why is this that this code has this particular provision? What is the theoretical basis with which this provision came into being? Then you would have to come back to the institutes. You would have to come back to for a master's, because that's where we give you the theoretical basis, which helps you understand. Now, where would that be useful? The theoretical basis would be useful when you encounter something that's not covered in the code book. That's where you need this the theoretical basis to stretch yourself beyond what the code has to say. So that's the balance there. So in terms of the 10 years of work experience and 7 to 8 years, I would say it would not depend upon the kind of projects you've handled along your way, what kind of experience you packed. I think that adds more than other things. And it also depends upon how applied you are, and if you are using other streams of information to enrich yourself. All of that works. There are B.Techs who just with a bachelor's degree who've gone on to become chief designers in top design companies in US. Even in India, in fact, we had in the industry seminar, the first seminar was given by a gentleman who was just a B.Tech, and he probably has done design consulting for some of the top bridges in India. They've done some very, very good work. So he was lucky, he got the right kind of experience, and then he has the intellectual curiosity to learn things on his own. So he's progressed in the field. Okay, so approximately how much earnings can be expected by a small and a new structural firm in small cities, as most people don't pay much? Yes, this is one of the problems in small cities, and that is the people's expectation, and that is because we don't have a proper licensure process in place. So anybody is a civil engineer, everybody is a civil engineer. Now, once we have the licensure process, then only civil engineers who are certified, the professional engineers, are the ones who can give you a design, they can stamp it. And then your value of the service you're providing goes up. So right now, because we don't have that, and unfortunately, when you go to the small towns and these places, yeah, what people would pay you or even value your service is very low, unfortunately. Right? Any other questions? It's just one
I guess,
question.
yeah, I guess this is one question, but I guess this would be last question because it's already 8 p.m. So,
It's 8
yeah,
p.m. and I think it's dinner time. So,
yep.
the conception of a structural engineer with over a decade of experience, you valued more than someone with a decade of work experience developing countries like India. Yes, that again depends upon the kind of exposure you've had. You could be in US, you could be working as a structural engineer, but if you've not had exposure, richness of the exposure, you've not handled the challenging projects, then it won't amount to much. But suppose you're even in a country like India, there are, I know of engineers who work for small firms, but the kind of projects they've handled and they have under the belt are just really impressive. So it all depends upon the kind of exposure that you've had, that the firm that you've joined, the kind of work that they do, which allows you to enrich your portfolio. Right? Okay, so I think.
Okay, so yeah, I guess let's end the session with a vote of thanks.
Yep.
So, firstly, I would like to thank each one of you for taking part in this event of the CES, and a big thanks to Professor K.V.L. Subramaniam for taking out his valuable time in shedding light on the overview of career options and career paths present in civil engineering. And again, special thanks for extending your time, sir, and answering each question of the audience. And before we end, just one small announcement. We are planning to expand our CES team, and you all will soon be updated through a mail about the roles and responsibilities available. So do consider joining our team to make an impact on the civil engineering family of IITH. So yeah, with this positive note, we are ending the event now. Thanks again for tuning in. Bye.
Sure. Thank you.
Thank you, sir.